The formulas for slope-intercept form and point-slope form are given to you. In slope-intercept form, remember that M is your slope and B is your y-intercept. In point-slope form, M is your slope and it goes through the point x1, y1. So that x1 is the x value of the point, the y1 is the y value of the point. Okay, first, write an equation of a line that has the given slope and y-intercept. Write your answer in slope-intercept form. So it gives you m is 3, b is -6, so y equals 3x plus a -6 or -6. 2 through 4, write an equation of the line that excuse me, passes through the given points. Write your answer in slope-intercept form. This piece of the directions is like part B. Part A, we are going to use point-slope form. So we're going to start by, we need the slope. So step 1 is find the slope. So we use the slope formula. Do we need to write the slope formula on these notes? Subtract your y's on top, subtract your x's on the bottom. So 4 minus a -1 over 3 minus a -2. That's 5 over 5, which is 1. So step 1, find your slope. Step 2, use point-slope form. And you're going to stick numbers in place of y1, in place of m, and in place of x1. So we're going to do y minus, which of these 2 points do you want to use? The point that has the negatives or the point that has the positives? Positives. I think positives would be easier. So y minus the y value of the point, 4, equals our slope, 1, parentheses, x minus the x value of our point, 3. Technically, we have now written an equation of the line that passes through the given points. But it wants us to write our answer in slope-intercept form. I just realized that says write you answer instead of your answer. That's really annoying. To write this in slope-intercept form, we just need to do a little bit of work to it. We distribute into the parentheses. And then what else do we need to do to get y by itself? Add 4. Y equals 1x, or just x, plus 1. So step 3 is distribute the slope and get y by itself. That puts your answer in slope-intercept form. Okay, number 3. Step 1, find your slope. I want you to pause the video and find the slope on your own. I found that my slope is -2. Did you get -2? Yeah. Okay. That goes in front of the parentheses in our point-slope form. We need to pick which point we want to use. And the good news is it does not matter which point you choose. When you get it into slope-intercept form, it will make the same equation regardless of which point you used. So the fact that we've got a -2 already in here, I'm actually going to choose the first point. So 1 is my x value. I'm going to highlight that with blue. 6 is my y value. I'll highlight that with yellow. So y minus the y value of the point, 6, equals our slope times x minus the x value of our point, 1. Now, if one of those points had negatives in it, if that was unavoidable and you had to use a negative coordinate, keep in mind that subtraction is in this formula, so you would have to do minus a negative. If that had been like a -1, 6, you'd have to do x minus a -1. So keep that in mind. You may have minus a negative in here. Okay, step 3, let's distribute this slope. we've got y minus 6 equals negative 2x plus 2. Get y by itself. Y equals negative 2x plus 8. Okay, I want you to pause the video and try number 4 entirely on your own. Okay, so how many of you got to this point and said, what do we do now? What number do we use for undefined? This is undefined slope. That means that this is a vertical line. The equation of a vertical line is x equals something. What is the x value in both of these points? 5. So x equals 5. If you want to check that, you could plot these points, 5, 8 and 5, 15. That's a vertical line at x equals 5. Okay, now we're going to use what we learned toward the end of the last chapter. We learned about parallel and perpendicular slopes, right? So now we want to write an equation that passes through the point 1, negative 6 and is perpendicular to the line y equals 3x plus 7. All right, how many of you have younger siblings? Anyone has younger? Okay, so even if you don't have younger siblings, just imagine this scenario. Your younger sibling goes out trick-or-treating and brings home this bucket full of candy. What are you going to do with that bucket full of candy? Are you going to take it? Or at least take some of the candy? Yeah. I mean, come on, be honest. You're going to take the candy from your younger sibling. Yeah. But are you going to take all of the candy? Or just the good stuff? Just the good stuff. Like the waxy, gross dollar store chocolate. You're not going to take that stuff. You're going to take the good stuff. So this equation right here is your younger sibling's Halloween bucket. The good stuff is the slope. The rest of it is the waxy, gross stuff that you don't want. So in that equation, I don't want the other stuff to confuse you. I want you to focus on the slope. So the original slope is 3. What is perpendicular to 3? Negative 1/3, which is kind of gross, but I think we can deal with it. Our point is 1, negative 6. So we need to write y minus the y value of the point, negative 6, equals our new slope, negative 1/3, times x minus the x value of the point. And if we need to kind of label this, that's where that came from, that's where that came from, and our slope came from here. We want to write this in slope-intercept form, so we need to distribute. We have y plus 6 equals negative 1/3 x plus 1/3. Subtract 6 on both sides. I did 1/3 minus 6, and I got the decimal negative 5.67. I'm fine with the decimal, or you could change it to a fraction and write negative 17/3, whichever you want. Okay, let's try one more of those. But I'm actually going to change this problem to make it a little bit nicer. We're going to say it needs to be perpendicular to y equals negative 1/2 x plus 5. What's the only number I care about in that equation I just wrote? The negative 1/2. The rest of it is junk. It's gross. Just get rid of it. We don't need it. Nothing. We just need the negative 1/2. So that's what you want us to use? Yes. So don't use the original equation there. Use the one that I just wrote, because the original equation is going to be another kind of gross one, and I don't want to do that. Okay, so the original slope was negative 1/2. What is the perpendicular slope? Positive 2. So we are going to use the slope of positive 2. It needs to go through the point 3, 2. So y minus the y value of the point, that number comes from right there, equals our slope 2 times the quantity x minus the x value of the point, 3. On your own, distribute your slope, get that written in slope-intercept form. You should get y equals 2x minus 4. How are you feeling about this? Better when it's a slope of 2 and not a slope of negative 1/3? Yeah. Number 7 is a little bit easier. Write an equation of the line that passes through the point 3, 9 and is parallel to the line y equals 5x minus 15. What's the only number that we care about in that equation? The 5. So cross everything else out. We don't care. We only want the 5. That's like the Reese's peanut butter cups of the Halloween candy. If you don't like Reese's peanut butter cups, I'm sorry, but I think someone must have hurt you as a child because they're amazing. Yeah. Or you're allergic to peanuts, in which case I'm very, very, truly sorry. Very, very, truly sorry that you've had to deal with that. Okay, so in this case, our original slope is 5. What is a slope that is parallel to a slope of 5? 5. Parallel slopes are the same. Remember, perpendicular slopes are opposite reciprocals. Parallel slopes are the same. So we are going to use a slope of 5. And our point is 3, 9. So y minus 9 equals 5 times x minus 3. And I can label all of this where these numbers all came from, if that helps you. Distribute, get y by itself. Okay, since there's a few more minutes left on this recording, I think I will just add in here, remember that parallel slopes is the same. Perpendicular slopes is opposite reciprocal. All right.